graph the function f of x equals negative 1/2 x plus 4. Well, what we're tasked to do is determine what kind of shape this graph should have. And when we look at the function f of x equals negative 1/2 x plus 4, a convenient way to analyze this would be, when we look at f of x, that could, it's indicating that f is a function of x. This all can be replaced with a second variable, y, for example. So we could rewrite this as y equals negative 1/2 x plus 4. And then we can look at, if we did make that replacement of the notation, function notation, we find, replace the f of x function notation with a single variable, we would find that the exponent on y is a 1, positive 1, and the exponent on x since the beginning is also positive 1. When variables present exponents of positive 1, they're called linear. This is a linear equation. And the equation associated with a graph that we would generate would graph as a line. So linear equations where both variables have exponents of 1 will graph as a line. That's the first thing. We really should kind of know, what kind of shape of the graph should we expect. Okay, now we could also, I might go ahead and rewrite this equation so we have a clean copy to analyze, how to graph it. We also realize that this equation, when it's written in two variables like this, is written in slope-intercept form. Here's what slope-intercept form looks like. Y equals mx plus b, where you have to make sure that the equation's already solved for y, meaning positive 1y equals the x term and the constant are on the right side, which our equation is. It has an invisible positive 1 coefficient for y, and so we're able to identify now what the slope is, the coefficient of x. Slope of the line that we're going to graph has a slope of negative 1/2. These pluses match, so the y-intercept is happening at y equals 4. So here come the information that we're going to use. We have, I'm just switching colors here. We're going to make the y-intercept happen. Y-intercept. We need 2 points minimum to make a line. The y-intercept, when you're dealing with an equation like this, hang on. I'm going to rewrite this. The y-intercept occurs at a point 0, b. This is an ordered pair where we would find the y-intercept. And what we find is, what we found out from analyzing the equation is that the value of b is 4. So 0, 4. That would graph as the y-intercept of this graph. So what we look at, we're going to graph the equation, on this blank rectangular coordinate system. 0 for x, of course, every ordered pair that we deal with in 2 dimensions. The first coordinate represents an x value, a value on the x-axis, left or right, and the y-coordinate represents a vertical value, up or down, along this line, which is also reflected as f of x. So here we go. The x value of 0 means don't move left or right at all from the origin, and the y value is positive 4, so we're going to go not left or right at all, but up 1, 2, 3, 4, and mark a point. This blue point represents where the line crosses the y-axis. It's the y-intercept. Okay, now we can use the fact that we're going to use the slope m to graph a second point. A second point. And the way we do it is we note that m equals negative 1/2. from the equation. We see that the slope is in the has negative 1/2 in its position, but the thing is, the problem with negative slopes when we read them this way is we must convert them to a negative fraction. I either can interpret it as -1 over +2, or we could use it as, I'm going to switch color, we could use this as slope as a +1 over -2. Both of those, this blue fraction and this red fraction, both mean the same -1/2, where the negative sign is outside the fraction. So let's use both of these and just see what happens. We're going to end up getting the same line. That's the hint. So if we go ahead and graph the blue slope in this version, we're about to employ the geometric definition of slope, which is rise over run. It means that from any point on our line, which the y-intercept is a point on our line, we could rise -1. Rise negative means go down 1. And then we're going to run +2. Running positive means go to the right 2. And we're going to do that from a known point, which this is. This is the y-intercept. So we're going to mark a point. We're going to rise -1, then run +2, and mark a point. And that gives us a line. Now, let's go ahead and draw that line. Let's see, what would happen here if we drew this line. Okay. Now, if we come back and see if we had turned the original -1/2 into this red slope, we would see that rise could have been used as rise equals +1, which would make us go up 1 unit from any known point. And then in this red way, rise over run would be -2, which means -2 for run means move left 2. Now if we go back to our y-intercept and we use this red slope, with the negative in the denominator, we would rise +1, rise up +1, and then run -2. And look what that gets us, is a point still on our line. If we had used that point, or this version of slope, it would have graphed us the same line. So the next issue that we have to determine is which of these answers show this graph, because we feel confident in our graph. So now we have to just make sure to pick the correct relationship. Now the other thing is, what we could use is knowledge that a negative slope means as we move to the right, this line is falling. I can quickly eliminate answer 1, because when we pick a point on the left hand of the line and move to the right, this line is rising. A can't be the answer. That's the line that's associated with a negative slope. The other one that's easy to eliminate is C. As we move to the right, this line is rising. That represents a line with positive slope, and we know we have negative slope. So now the idea is to distinguish between answer choices B and D. B has, if you notice, B has a y-intercept at -4. We know this represents a line that has a y-intercept at -4. And that's not right, because we know that our y-intercept is at +4. So far, all indications are showing us that answer D is most likely our choice. So here's a line with a y-intercept at +4 on the y-axis, and if we look closely, if I reconstruct the red, +1 rise over -2 run, from this point, with this y-intercept on the D graph, we would rise 1 and run -2. So using the slope, the red slope, we are able to recreate the slope that we have. I could even, if I had time, feel better, I could use the blue slope, rise from the negative, from our y-intercept. We could rise -1, run +2, and look, we're able to recreate the line. Verify that this line represents the true function -1/2 x plus 4. The correct response to this question is D.